Hi, and welcome to the videos for section 1.2 for Math 126. This is the first of 4 videos for this section. In this section, we're going to be looking at exponents and radicals. So the first thing we're going to deal with here is integer exponents. So you see integer, that means what? It's the counting numbers, it's 0, or it's all the negative numbers. Our definition says that if a is any real number and n is a positive. We're looking at the positives to start with here. We'll get onto the negatives in a little bit, but if n is a positive integer, then the nth power of a is written as the following. So a to the nth power. The a is what's known as the base. The n is what's known as the exponent. This notation means we have a multiplied by itself n number of times. So it's not a times n. It's not just a multiplication problem. It's the value a multiplied that many times over. So for example, if I have 2 to the 4th power, this doesn't mean 2 times 4, 8. Okay, I'm done. No, this means 2 times 2 times 2 times 2. I need 4 of them because my exponent is 4. So that's what? 2 times 2 is 4. Times 2 is 8, times 2 is 16. So 2 to the 4th power is equal to 16. What if I have negative 3 squared? So that means what? It means negative 3 times negative 3. I need 2 of them because I have, the exponent is 2. Negative 3 times negative 3 is positive 9. So negative 3 squared is positive 9. You don't have to put the positive sign there. I just wrote it there to emphasize that we get a positive value even though our base was negative. So that was for positive exponents. We also could have 0 or negative exponents. We have the following. If a is not equal to 0, and a is a real number, and n is a positive integer, then a to the 0 power is equal to 1. So basically what that means, as long as a is not 0, any number to the 0 power is equal to 1. And a to the negative n power is the same as 1 over a to the positive n power. So you might have seen this before. You might have been told this in class, and it's like, okay, anything to the 0 power is always 1. It just is. Just believe me. Just go with it. But why? Why is this the case? And why is a to the negative power the same as 1 over a to the positive n? So let's look at a little example here. If I have 2 to the third, so that means what? 2 times 2 times 2, which is equal to 8, right? What if I have 2 squared? So this went down by 1. 2 squared is what? 2 times 2, which is 4. So from 8 to 4, I divided it by 2. I divided it by whatever my base was. So the exponent went down by 1. I divided my answer by the base. So how about 2 to the first power? Well, 2 to the first power is just 2. So again, I divided by 2. Now that gets us to what? 2 to the 0 power. So this dropped by 1, which means I have to divide this by 2, which is 1. And it's going to work out that way for every single number. If it's 3, 3 to the first power is 3. 3 to the 0, well, I have to divide by 3, so again, I get 1. So then how about 2 to the negative 1? Well, again, the power just went down by 1, which means I have to divide by the base, divide by 2. So 1 over 2 is 1/2, which is the same as what? 1 over 2 to the positive 1. 2 to the positive first power. And if you do one more, 2 to the minus 2, well, that's what? Divide this again, 1 over 4, which is what? The same as 1 over 2 to the positive 2 power, 4. So that's where this information, this formula comes from. So you don't have to just say, hey, but I'll be honest with you, there's going to be times at the semester where I'm going to be like, look, you just got to take my word for it, or it's in the book, and you can follow up on it. Some stuff we just don't, even with the videos, just don't have time to get that far in the depth of it. But if you ever want to know it, oh, actually, let me read that. If you ever want more insight or more explanation, you guys always are welcome for office hours or ask it in class. Be happy to answer at any of those points in time. So let's look at some examples. 2 quick ones here. If I have 4/7 to the 0 power, well, based on what we know now, anything to the 0 power is what? It's equal to 1, as long as this number isn't 0, the base. If I have second example, -2 to the -3 power. What did I tell you earlier? If you have negatives in a problem, slow down. Be careful with what you're doing. So this value, based on our formula, is the same as what? 1 over, the base didn't change, right? A was still A. The only thing that changed its sign was the n value. So my base still stays the same, -2. I have to leave the negative sign there. It's the 3 that now gets a positive value. So this is what? 1 over -2 times -2 times -2. I need 3 of them. -2 times -2 is +4. +4 times -2 is -8. So this guy is -1/8. So that's it. That's video 1. Fairly concise. I wanted to make this short because I wanted to keep the next bit of information that I give you in video 2, our law of exponents. I wanted to make that its own separate video because I promise you'll be going back and referencing that quite a bit throughout the semester. And not even just this semester, but maybe on into 127 and 181. I see people struggle with the information in video 2. So anyways, that's the end of video 1. Come on back and we'll deal in video 2.